All right, looks like we have quite a few people joined in and a lot of people chiming in on the chat. That's great. It looks like all over the world, Western Australia, Ghana, BC. All right, great. Let's go ahead and get started. So welcome to today's webinar on geotechnical considerations in open pit blasting. I'm going to give just a little bit of a background for you. So this webinar is brought to you by the Geotechnical Center of Excellence. You might know it as the GCE. We are a little bit of a different organization. We're an industry-funded and member-led group. We are part of the School of Mining, Engineering, and Mineral Resources at the University of Arizona. Sorry, we just changed the department name, so I'm still getting used to it. And our charter is really to bridge gaps within and between academia, industry, and fields of study. And we pride ourselves on conducting collaborative research and providing education opportunities like this webinar that you're tuned into today. So as I mentioned, the GCE is member-funded and member-led. So here is a list or graphic of our member companies. Without them, none of this would be possible. So a huge shout out to all of them. If you would like to become a member of the GCE, you can message any of us at the GCE or send an email to gce@arizona.edu. We'd love to get that conversation started with you. So again, huge shout out to our membership. So this webinar is based on our newest professional development course titled Blasting and Pit Slope Performance. You can scan it today. It is like all of our professional development courses. It's fully online. It is recorded videos. It is ongoing right now, but it will be open for about a year. So you can scan the QR code there to learn more about it. And you can learn about all of our other courses as well on our website, which I think one of my trusty colleagues will post in the chat. So for this course, I want to give a huge shout out to our lead technical advisors, all of which are joining us today. I'll introduce them more formally in a minute, but we've got Pat Jenks, Phil Morris, and John Silva Castro joining us today, as well as some other expert panelists. And a big shout out to the Large Open Pit Project for underwriting this course. Without their help, none of this would be possible. Trust me, it's a lot of work. So just a little bit of housekeeping. If you're tuned in today, you are muted and your video is off, so don't worry about that. If you'd like to ask a question, please use the Q&A function at the bottom of your Zoom control panel, or it might be at the top. It looks like the chat, but it's specifically for Q&A. So we encourage you to use both the chat and Q&A, but if you have a specific question, you can use the Q&A, and that helps us find your questions. You can also pose your questions anonymously if you'd like. You can also vote for other people's questions. So if there's a question that you really like, you can give it a thumbs up, and we'll see, maybe there's a question that a lot of people want answered, so we can high grade that. This is also a recorded webinar, and we will post it to our YouTube page following this recording. And maybe one of my colleagues can also post that link to the YouTube channel. Just a quick note to please note that the views and opinions expressed by our panelists are their own and do not necessarily reflect those of the GCE or any affiliated organizations. All webinar content is intended for educational purposes only. It is not intended to be a substitute for site-specific professional advice or analysis. So thank you for bearing with me through that. So now let's get to some quick introductions, starting with the Geotechnical Center of Excellence webinar team. I'll start with myself. My name is James McNabb. I'm a Senior Research and Development Engineer here at the GCE. I'll be your moderator today. I'm joined by our director, Julia Potter. Hello, Julia.
Hello, James, and everyone. Thanks so much for being here today. Looking forward to a great discussion.
And I'm also joined by Cheryl Bukowski. She is our Professional Development Program Lead. Hello, Cheryl.
Hi, everyone. Thank you for joining us today.
All right. Now I will introduce our expert panelists, starting with Pat Jenks. He is the Manager of Geotechnical Engineering with Nevada Gold Mines. He is also one of the lead technical advisors for this course. Hello, Pat. Thanks for joining.
Hi, James. Thank you. Thanks for everybody joining this webinar, and welcome.
All right. Next, we have Phil Morris. He is a mine engineering consultant with Philip Morris Mining Solutions, and he is also a lead technical advisor for this course. Hello, Phil. And it's very early in the morning, I know.
Yep, good morning, but I see we've got people from a lot of countries where it's nighttime as well. So welcome everybody, and I hope we have a good session today.
Yeah, Good observation. Yeah, we got people from all over the world here. Okay, next we have John Silva Castro. He's an international consulting manager with Dino Consult, and he is also a lead technical advisor for this course. Hello, John.
Hi, thank you, James, and thank you everybody for joining today.
All right, next we have Greg Abrams. He's a principal consultant of engineering geology with BGC Engineering, and he's also a course contributor to the blasting course. Hello, Greg.
Hi, James. Hi, everyone. Yeah, thanks for having us. Looking forward to it.
And we have Ray Yost. He is a principal specialist in rock mechanics with Tetra Tech. He is also he's not a lead technical advisor for this course, but he could be. He is a contributor to the course. Hello, Ray.
Hey, how's it going? Thanks for having me for this. Looking forward to the discussion.
Yeah, thank you. So to start off, we've got a couple of kickoff questions. The first one I will pose to Phil Morris to get us started. And then once he's done answering, I encourage everybody else to chime in if you so choose. So this first question, how do you communicate blast objectives and feedback between operations, planning, geology, and geotechnical teams? What works and what routinely breaks down?
Okay, good. It was a good place to start. It's too many facets to the question, but you've got the key stakeholders identified there in that question. So maybe the way to start this is to think, what are the objectives of each of the stakeholders that we're dealing with here? So we've got long-term planning, and long-term planning obviously are mainly interested in the adherence of the design to their criteria and their pit stage design outlines, and all the parameters that include the cutback widths, the inter-ramp angles, and the production rates. So they're sitting off to one side, but got a vested interest. Short-term mine planning is obviously talking in a more detail now about the layout of practical blast designs, separation from trim, limit blasts from production, but still achieving the operational movement rates, achieving the wall design criteria, bench face angle, design berm width, etc. On the operations side, we've got the two primary criteria thereafter. I mean, in my experience, obviously in mineral, fragmentation and diggability are the key objectives, and it's not slope stability. But achieving planned equipment production rates is another primary concern, and then maintenance of adequate blasted stocks on the ground, etc. And lastly, we've got the tech services. We've got geology, geotech, and the associated groups survey. And they're the ones that are trying to, their needs are related to the control of blast vibration levels at the wall, trying to achieve the design criteria for effective berm widths, minimize crest loss, and the integration of all the technical side of things into the blasting process. So how do we get adequate feedback? I mean, one thing that I've come across a lot is that if you have shared KPIs, key performance indicators, they're often ignored in a mining company, and operations KPIs and your bonuses perhaps are associated with productivity, production levels, and the fragmentation. Whereas for the geotech guys, it's obviously totally different. Now, if you can find a way to merge those key performance indicators, that's a good way to try and bring everything together so that everybody's got a joint and focused effort. Then you obviously need a structured blast design and review process, which that will get talked about later, which is like a blast master plan that involves all of these stakeholders in the limit blast design process. And lastly, I think we need a feedback process that ensures that any monitoring and measurement of slope performance, as in a QC, quality control, QA/QC, is used to make sure that you have and achieve continuous improvement. What doesn't work though, or what breaks down, just to wrap up, production pressures are something that's always in the background in a mining operation, and day-to-day pressures to move, adjust, change the blast designs because of the needs of operations can cause some significant issues. The lack of communication and the lack of alignment of objectives. So it's some of the reverse of what I just chatted about. I'm sure that's enough to get started. So back to you, James.
Fantastic. Thank you, Phil, for getting us started there. Very great, thorough answer. Would anybody else like to chime in?
I think one thing to add on the communication piece is that what I've seen break down is when we talked about all these different teams, and that's a great, way to look at that structure of who needs to be involved. But when we start to talk about objectives and things from the perspective of our own discipline, you get a geotech in there talking about geotech things and a blasting person talking about blasting things. Sometimes that language is not universal, even though it should be amongst everybody involved in the same objective. You go out and I'll just pick on geotechs, but they go out and talk about the geotechnical goals. And sometimes people outside of geotech have no clue what you're talking about or why it's important in anything. And so really talking about things in a way that's using our own discipline specific language can cause a lot of problems. And that's something that I've seen break down quite a bit, where I'm talking, but nobody understands what I'm saying, and vice versa.
Yeah.
Great.
Yeah. No, I would agree with that. And, as I think about this, there's a couple of things that are on my mind, and part of that, Ray, is a bit about what you spoke on your a couple of modules that you produce, which is all the other aspects of mining. There's, what impacts the MPV, equipment utilization, U of A, drill availability, all those other things. And if the geotechs can understand that and know that, you don't have to be experts in it. But if they can talk that language and appreciate there are many different goals here, even if we talk about recovery and throughput, having a little bit of an insight into all those different views, I think is appreciated. And I think it then helps people, whoever's really going to drive this wall control blasting program, it'll help them pick their battles. You may not need to do and spend a lot of time, effort, and money on pre-splits and trims everywhere. It may only be you may only need to do it in certain areas. So I think, understanding that bigger picture and the whole value stream is useful there. And then just another thing for me is maybe that soft skills. I think it's rare to see an org structure which is perfect, especially when it comes to drill and blast. Solid lines, dashed lines in the org structure, I think that needs to be almost put to one side if possible. And again, whoever's leading this, and part of it, having those soft skills to win people over and work with people and persuade people is hard, but it's critical.
Yeah, very good.
Great.
I think one of the other key things is making sure that all of those groups are aligned on what the objectives are. And not only that those groups, planning, geology, geotech, are aligned, but the leadership has been communicated with, so they are understanding of what controls we have in place to achieve those objectives. And I would say that latter part is often the something that is routinely breaking down. And I think it's beneficial to develop a regular cadence to review what those objectives are and what those controls are, and continue to communicate that not only among the technical groups, but with leadership.
Yeah. Okay. Great points, everybody. All right. I think for the interest of time, we'll move on to the next question here. This one is for Ray. When considering slope stability or wall control and blasting, what are the most important pieces of information you need before blast design begins?
Okay, I'll be really curious as far as what the other panelists have to say about this one too, but I'll give it my best shot here. Easily the first thing you need to know before you even get started is something about the geotechnical environment. One of the key pieces is obviously hydrogeology. That's the easy one. You have to know if you're getting to a wet or a dry area. But then, of course, following that is the rock. You need to know these basic characteristics of it. Not everything maybe, but fundamentally, how broken up is it already, the RQD or whatever the measure you want to use, the hardness or strength or weathering, your cementation. What is it about that rock that you need to understand to design that blast? If there's stratification, changes within the blast pattern, and then those rock characteristics. And then structure is hugely important. We really can't stress this one enough. Both the large scale structure, in terms of directing that blast energy down these pre-existing structures, or even the small scale structures, if they're going to be impacting the design, or if the design is sensitive to that structure. So anything that the design is sensitive to, you really have to understand not only how close the blast is to it, but also where that blast energy is going relative to that structural orientation. So really, thinking about how you lay out that pattern relative to directing energy along that structure. This next piece is a bit of a chicken and egg problem, because you need to know how the rock is going to react to blasting before you start blasting it. But to understand it, you have to blast it a little bit. These are things like, signature holes to get this sense of the waveforms, and if you had it, peak particle velocity versus scale distance graphs. Some of these just fundamental pieces around how you start to design that blast, and the timing between holes and the impact it has on the rock, and all sorts of different things as well. And this is somewhere in between these first two pieces, is this difference among different areas of the pit. You're not going to have one blast pattern for the entire pit. You're going to have areas that are going to have different sensitivities to blasting, or any different blast designs. And it's, partly the geotechnical environment, but partly understanding how blasting reacts, or how the rock in each of those geotechnical environments reacts to blasting. And then this last piece, it really comes back to what we keep talking about here. And I sense this is going to be a theme. You just have to understand the objectives of that blast and the different trade-offs that might be involved in any one particular blast. Are we trying to focus on design conformance and stability versus fragmentation? Are there parts of the pit where we might focus on one or the other more? Certainly in production blasts in the middle of the pit, we could probably look at fragmentation. But you get closer to the final pit slopes, probably more design conformance. Blasting economics, and this sort of the small scale, economics around the drill and blast costs versus the larger operational economics, considering the crushing and design conformance costs and things like that. So really just, getting everybody, again, just to echo some of the previous statements, everybody aligned on what is the purpose of that particular blast. And again, it's not going to be the same for every blast. There's going to be parts of the blast as it shift around, or parts of the pits as you shift around, that'll have very different trade-offs. And understanding how that shifts as you go and blast in different parts of the pit is of considerable importance as well. So quite a bit to think about even before you get started.
Yeah, great. Thank you, Ray. Anybody else like to piggyback on that?
Yeah, I suppose I could add just one thing that I think about is the actual capability of the operation. Often, you can't ask for the moon on a stick if you haven't got a stick, and I think that applies to blasting. Like you may want the best pre-splitting and the best drilling accuracy and really fancy loading if we're putting in decks and all this sort of stuff. But are the guys on the ground actually capable of doing such things? And even looking at this picture in the background, I mean, if you're working in -40, doing complex loading is miserable. I've done it, and it's horrible. And I think trying to come up with a design that can actually be implemented is critical, especially if it's a sort of a new concept. You're coming in, you're going, look, we have to change our practices. Production's fine, but we're just killing the walls here. the blast design needs to be as simple as it can be for the crews on the ground.
I just will summarize all the things that you guys are saying is limitations and your restrictions. You have to control PPV. You don't have that problem. You have to doing this blast for fragmentation, as was saying by Ray. I mean, also the purpose and the limitations of the blast. As you have enough free faces. You don't have is confined. So all those things need to be accounted. Yeah.
Just one other thing to add is that, Ray talked about the structure and the rock fabric, smaller scale structures. Another couple other key things we need to make sure we're keeping in mind with respect to slope stability and wall control as being important before you design the blast is things like the lithology and the alteration, because that's going to influence that pattern design as well as your product selection.
All right, fantastic. Thank you all for that. All right, let's move on to the next question here. This is for Greg. Which factor in blasting, for example, burden, spacing, powder factor, geology, etc., tends to have the biggest impact on fragmentation and slope integrity?
All right. Well, luckily, I think we discussed quite a lot of this already. I mean, the immediate answer up front is geology. The geology controls, for me, everything. However, it's the thing that we cannot control. You're given what you're given, and we can control all the other aspects of it: burden, spacing, product, all the rest of it. So from a fragmentation standpoint, I think it's all about energy, and when we want to start to break stuff down, burden and spacing, which will then impact the powder factor, obviously, are probably going to be one of the most critical aspects here. And then product also becomes important. For a more massive rock, you will need something maybe with a higher velocity of detonation. If you're dealing with a much higher fractured rock mass, you might only need to give it a light fluff, and the whole thing will just break into small pieces beautifully. And it will be a cost trade-off when it comes to fragmentation. With massive rock, we will be tempted to tighten up that pattern and put more energy into it, improve the fragmentation, but it will come at a cost. And at some point, that cost will be diminishing returns. And also, depending on the processing, you may not want too many fines, as that can have issues on the recovery side of things. And then moving on to the slope integrity, well, that might depend. Are we talking about sort of the near field or the far field? Are we talking about a scenario where we're double benching and we're triple benching and we want to have a beautiful face and we don't want any crest loss because it's a rockfall issue? In which case, there's going to be the case of trim blasting and pre-splitting, and confinement is a big one. It's given sort of spoke about in different ways, whether we talk about face burden, but the confinement of the shot, how much energy, how can we move the muck out of the face and we don't hit the wall? And then, well, I suppose the last part of slope integrity is if we're mining below or close to an instability, then there's the vibration piece. Perhaps we're talking more about getting into the far field there. And that's where our frequency control timing can come into play, the value of doing signature holes, understanding the PPVs and developing a site law and so on. So, and I suppose just lastly, one other thing I would say is bench preparation It's such a big, set yourselves up for success. Make sure the bench is smooth, it's level. We haven't preconditioned it so the holes don't collapse. You're only going to get good results on fragmentation and slope integrity side if we can drill straight, if we can drill accurately, if holes aren't collapsing. So I think bench prep is really key as well.
Great, thank you, Greg.
I'll add to that what Greg said. The latter part of his answer, I think, is a very key point that often gets overlooked. We saw a recent operation where they were having blast performance issues or drilling performance issues where they were losing 15 to 20% of their holes due to cave-ins or bridging of the holes. And they weren't asking for redrills of those holes. They were just pulling the patterns in, increasing the powder factor, and really, really hitting the rock, the pattern, and the slopes were hard. That resulted in more performance issues with respect to the high wall. So I think that's a key fact that might get overlooked that we definitely need to key in on.
Actually, I like your answer to this question, Greg. When I had looked at this one initially, I was trying to get it down to one thing. And I really couldn't come up with just one thing that was the most important one. And I like that you basically said that all of these things are important. And it is really hard to get it down to kind of just one or two things that are having the biggest impact, because so many pieces do factor in certain ways, and you can't really pull any one out and say, well, that's not as important. I kind of avoided this question, but if I had to answer it, I might say that dispersion in the pattern is really important. We tend to have a tendency in blasting to make it easy on ourselves. We're going to drill a hole and put the product in the bottom of it, and then stem the rest of it and blast it. Whereas when we start to talk about decking or dispersing that, anything that disperses that product throughout the hole a little bit more, especially to Pat's point about having differences in the lithology or alteration along the height of the pattern, and we want to start to put different energy into different parts of that pattern, I think that could really have a significant impact on the fragmentation outcomes.
If I just add a quick one too, none of you have mentioned blast hole diameter, and we do a lot of, or I see a lot of places where you do a lot of hard work with decking and messing around, if you like, but you're still working with relatively large hole diameters, and often the most successful way of controlling or improving slope integrity is to work with smaller holes and getting better control of the distribution of energy in the blast. I'm sure we'll talk more about that anyway, and John can come in there somewhere too.
All right. Great. Thank you all for that. We'll move on to the next question, which I believe is for John. Are there efforts underway to utilize artificial intelligence or machine learning in blasting? For example, using historical blast data to build site-specific machine learning models? John?
Yeah. We have been through different industrial revolutions. I was preparing something about this, and we are in the fourth industrial revolution, right? Where we digitize or make digital everything we have around. And of course, mining and specifically blasting is going through that process too, And I will say that digitalization is in two stages. The first one is for modeling. Let's go to say when you design a blast, you would like to know what the fragmentation is going to be, what is going to be the vibration that particular blast is going to produce in some specific parts of the slope, for example. You want to see how the movement of the material is going to be. So we have all the tools and many blasting and explosives companies are working on that. And also then once we have the modeling, I think all industry, explosive industry companies or people working on the explosives is more or less is complete. And now the second stage is the connection of that modeling with AI and these systems that allow us to see beyond what a human being is capable, right? And they, of course, working based on data. So now we are seeing the trend of you do the blast. Now with the drones, we just fly, check the data, check fragmentation. During even the recording, there are systems that allow you to see how the movement of the material. So we collect all this data, and then we put together with the AI help and start to do the analysis of how was the design, how the blast performed, and what we can improve next. So yeah, definitely we are going through that process, you know. So the effort out there are going through. There is not a particular system, and everybody's working on that in the industry. I will say that.
All right. Thank you, John. Anybody like to chime in on this? It's definitely a hot topic. I think we'll be learning a lot more about this in the very near future. All right. We'll get to our last kickoff question here, which is for Pat. Could you provide an overview of a blast master plan? Why are they important? Who should be involved? What do they include? And when should they be implemented?
Thank you, James. Well, I would argue that the blast master plan is one of the key planning workflows that sets us up for success to achieve those objectives that we outlined earlier on in this webinar. We need to reach out to those key stakeholders. That would include the drill and blast engineering team, the blasting operations team, geotechnical engineering, geology, and the planning teams. And the goal here of the master plan is to prepare a plan that identifies all the key information that we're going to use to set ourselves up for that success, obtain those objectives. And that would include things like all of the key faults, the key lithologies and contacts, alteration zones, have the blast hole layout set up preliminarily for production for trim patterns. You could also include in that, preliminary thoughts on where you might have pattern breaks and the like. One of the key things I like to advocate for at this stage is that the drill and blast engineer includes what we call a pre-trim row in that last row of the production pattern, so that we can create a uniform burden in front of the trim rows to set us up for good wall control. And then discuss this as a team. Let's look at where the pattern layouts are relative to the faults and the lithology contacts. We don't want to be breaking patterns on fault contacts where you stop a pattern at a fault, it sees energy that time, that during that shot, and then you start it at that fault again and it sees some energy a second time. So we want to try and avoid things like that. We want to talk about the historical performance on the benches up above. How did that high wall perform when we shot it last time? What worked, what didn't? What kind of changes might we be thinking on this next bench? And that often involves not only an office meeting, but oftentimes a field visit. And many of our operations actually have set up benches or tables out in the field so that they can gather this key group of stakeholders around that table out in the field and point to how things have performed or not performed, and then discuss alternative solutions. Talk about the geotechnical domains and the design assumptions that go with them. Oftentimes when we receive a geotechnical report from a consultant or we develop it internally, we have some key criteria for that wall control shot. For example, you may have one slope design that indicates an in-ramp angle of, say, 42 degrees if we're shooting production patterns up against final high wall. But if we're shooting a free face trim or a free face trim with a pre-split, maybe we can steepen that up to, say, 44 degrees or something. So understand what those key design assumptions are going into that. Discuss the blast timing domains. Where do we, based on the lithology, the structure, and historical performance, your signature holes, where might those domains be? That might also drive changes in where we have pattern breaks. Identify where you have those signature holes to support that part of the discussion. We also need to talk about the points of initiation, the timing and the loading of those shots. And oftentimes, we talked about the structure. Ray talked about structure being an issue earlier in the webinar. We may have to consider things like directional shooting, and that might drive what the mining sequence is and what the mining rate needs to be. So we need to have those conversations at that blast master plan meeting. And then other things that we need to be discussing during that blast master plan are identifying and quantifying what the performance indicators are and what those objectives are. Things like vibration monitoring. What are the PPV thresholds? What are the frequency thresholds? Are we achieving spatial compliance? Are we getting our toes and crests in the right spot? What are the face conditions looking like when we scale back to final high wall? We also need to talk about things like the bench reliability and the conformance. Are we achieving our targets? 80% reliability, 70% reliability, whatever it might be, depending on your design acceptance criteria. And the shovel performance. Are the shovels being able to mine that muck properly? Are we what's the fragmentation like, et cetera? And then this is also a good time to review our TARPs to address nonconformance. Keeping in mind that wall control blasting. It's all one of the key things here is it's all about that bench reliability to protect people from rockfall hazards and the like. That at the small scale, and if the design is not being achieved, there are two options that we have. One is the operational performance needs to improve, or alternatively, if we can't do that, the design needs to be adjusted to accommodate it. So that's a good time to discuss that and what the TARPs are in place to trigger those decisions. And then at the end of the day, this all needs to finish with a full team review and sign off. That would be my view of the blast master plan.
That was a masterful response, Pat. Thank you for that. Anybody else like to chime in on that? Very thorough response.
Tough to add to that answer.
That's what I was thinking.
Yeah.
I mean, and it's a smaller caveat is that these are very much living documents. And in terms of when they should be implemented, it should be pretty regularly that they're reviewed and sort of re-implemented. And as anybody comes into the organization or whatever, they're reviewing it and signing off on it and asking questions. So it's a lot of keeping it alive throughout the operation. There's no sort of singular win.
Yeah.
Great. And the thing that, if just listening to Pat talk and list all those quality things that need to be done, it just sort of reinforces, that collaborative piece that is, D&B and wall control blasting, and how many people need to be involved and the impact it can have on the mine plan. And it just can't be done with, just a couple of geotechs or just a couple of planners. It's such a group effort.
If I could add one final comment there, because I've been a long-term planning engineer, the whole process can get pushed really hard because vertical rates of advance from the long-term plan are excessive, and you're in a relatively small environment reaching towards the base of a pit, and they're trying to maintain productivity rates in the long-term plan, and this causes all sorts of flow down issues into the how we structure and run the blast master plan system, and I think I'm a big one for saying that there needs to be feedback to the long-term planning group who aren't necessarily associated on a routine basis with this process, but you can only do what you can do if within the guidelines or the things that you're forced to do in terms of rates of advance and the amount of kilometres of wall you're producing in a year. So they're things that need to be thought about too, right up front.
Yeah, maybe that's the comment, Phil. It's like when you say you can only do what you can do, maybe that also applies to, don't be put off if you can't do the Rolls Royce that Pat just listed. I do think, start small. Anything that you do is a bonus. Get this thing going.
All right. Fantastic. Well, that was a great answer to that question, everybody. I'm going to jump to some live questions now from the audience. First, I'm going to start with, actually, it's not really a question, it's a statement on some of our previous discussion, but I think it's a really good one. This is from Alan. So I'm going to pose this statement, and then we can chat about it if we want. So a factor that could impact fragmentation and slope integrity that may be faux potting up blaster or worker experience and ensuring clear understanding of blast procedure and changes as needed as encountered during the loading process, which is also known as charging in the Southern Hemisphere, may go without saying, but should be considered as well. So it's really, really good point by Alan. I don't know if anybody wants to make any comments on that.
Well, other than to encourage professional development and ongoing education, I think that's a key aspect of this. Mm-hmm. Improving that blaster workers' experience and educational development.
Yeah, I would say spend time with the blasting crews. If you've done a lot of the theory, spend some time on the ground loading the holes and with the blasting crews, and understand if can the truck squeeze in down by the rows if you've tightened the burden up too much, and can they load it properly, and is the hose, are they loading bottom up, and some operations, when I was at Rio, they were very good at giving people the opportunity to shift between roles, especially in the sort of junior intermediate levels. And I think that proved very valuable if we had D&B person that had been in geotech and had done some mine planning as well. That was certainly very valuable.
I think you actually raised a really good point about the folks spending time with the blasting crews. I know I enjoyed going out and just talking with them, because it works both ways. I learned a lot about what they were up against and some of the things that they were thinking of. And it was also a chance for me to talk about, what I was looking for and what I wanted. And it's a great sort of informal or formal, in certain ways, information exchange as a way of getting that integration that we've been talking about, with all being aligned on what the purpose of this blast is. Because, you can't just sort of lob sort of presentations at people in training. You got to go talk with them one-on-one sometimes.
Yeah, no, for sure. Yeah, I loved the blast. That was the best bit.
Oh yeah. Plus, they let you fire the shot a lot of times too.
Yeah, exactly.
Fire in the hole, and those are good memories.
Yeah, great fun. Okay, excellent. Thank you for the comment, Alan. All right, let's move on to another question. This one is from Karen. There's been a lot of talk in my organization about eliminating trim shots and providing relief through optimized burden and spacing in a combo pattern. What are your thoughts on this? Some of the literature they cite is as follows, and I won't go through the literature, but she was kind enough to provide that for us. So if somebody wants to hop in on this one.
I mean, I could start the discussion, and I have
bet.
some opinions on this, which I think will be interesting to see what the rest of the panel think. But there's definitely, I've been to sites where they've been doing non-traditional stuff. They've shot the pre-split with the production, they've combined a production with the trim, and they've had a big production, and the results were amazing. And so there's plenty of case studies out there where they're, doing all this stuff and then tweaking the timing, and the results are great. And I think part of that is good practice and good QA/QC, and a lot of it's just good rock. If you're blessed with good rock, fabulous. But I do think it's a case by case basis. You can do all the reading that you like, but I think to prove this out, it's about maybe drilling a hole behind the bench and sticking a camera down it before, shoot the shot, stick the camera down afterwards, put the cones out on the bench, put the seismographs out on the bench, and just look at the data. What's the rock telling you before and after the shot, and then modify it accordingly. Try a modified production with it and vary that standoff distance. Try the trims and look at things like confinement. Look at your free faces. Are they steep and clean, or are we saying, look, we've got a free space, but actually it's slopey and you could walk up it and it's not really giving you any burden relief whatsoever? So I think for each site, just take that proactive approach. I don't think there's one. And there could be many solutions to you could probably try a few different options and they may all work. But I think it's a site-specific approach, and it's a case of getting out there and looking at the data and adjusting the blasts accordingly.
I'm sorry.
Go ahead.
Go, Ray.
I was just going to say, to add on to that, I mean, there's never going to be a one-size-fits-all approach to this. You had mentioned like good rock, you're going to have a lot of good success, but to get into more complex situations or poor quality rock or very heterogeneous rock might not be as easy to achieve those. So sort of don't get sucked into the idea without understanding the context in which the idea is created. Just added to that really quickly is the relief you have on the blasts. I think a lot of it's going to be tied into how much these are free face blasts or how much they're choked into something else. But go ahead, Phil.
Yeah, just speaking as a member, I sit on several geotech review boards, or GRBs, which I assume a lot of the people who are involved in this course are aware of, because they are subject to them once every year. But one of the problems I see is that there's a real push to believe that you can still control the vibration at the wall effectively with big blasts and avoiding the trim shots. And my experience over the last 2 or 3 years, I haven't seen, I don't think I've found one mine in the last 2 years where they've been achieving that successfully. And the problem is that your theoretical distribution of energy and the design that you've got predicts vibration back at the wall. But if you don't actually measure what you're doing on a routine basis and see if the reality agrees with the theory, then what we find is, and I think the free face thing is an absolute classic, that you end up pouring energy back towards the wall. And I've seen some really bad outcomes from getting rid of trim shots. I mean, I'm afraid the theory seems good, but I'm sitting on the side of saying we should still try and trim separate from production blasts and not doing the combo blasting patterns, because I'm seeing a lot of evidence around the world that it's not working properly at the moment, and there's some more controls needed to make things work better.
I will add to that is blasting definitely is an art. I mean, it's a science behind, but at the end, and it's funny because in geotech, Carter Sagi, he was talking about observational methodology, right? That you see the phenomena, check your math, check your models, and make adjustments, right? So it's not that simple that let's go not to use the trim shots. No, you have to even try, do trials. At the end goal is to protect the slope. Don't push the energy to the slope. So it's not a single answer, It's kind of like that. So, yeah.
One of the key aspects of this that needs to be considered is what's the recoil direction that modified production or combo shot's going to have relative to the wall. Just echoing some of Phil's observations, we have collected a significant amount of data in a couple of our pits recently where the operations leadership was adamant that they wanted to shoot modified productions and confined trim shots. And what we found is exactly what Phil says, is that what we see is significant increases in ground vibration as a result of that confinement of shooting a trim against a production or between the wall and a production, or shooting a modified production. And when we free face that trim, we get dramatic decreases in what that ground vibration is. So it's not a practice that I support, but to echo some of my colleagues' earlier comments, it's a case by case basis, and you really have to have good data to support it before you go down that path. And to Phil's point, I don't think a lot of people are collecting that data to make informed decisions.
All right. Fantastic. Thank you all for your contributions to that. And thank you, Karen, for the excellent question and providing all of those citations. All right, let's move on to another question. What key aspects should be captured for blast reconciliation, in particular to improve slope stability? And this is by Jaffney. Thank you, Jaffney. And I think I'd like to start out this question with John, if you don't mind, John.
Yeah, now with all the technology we have, the radars, we can check if the geometry definitely was follow the design, right? The vibration, we need to capture vibration to make sure that we are not pushing a lot of energy to the slope. So yeah, I will say those key movement, most of the big open pit mines, you have radar movement, control the velocity of the displacements. So all that information, the important thing is not just to collect them, but also to have some parameters to evaluate performance parameters. What PPB we will allow, what movement of the slope we will be trigger higher flags or things like that. I will say that. And of course, you need to play with just not the slope. You need to respond to the processing plant fragmentation. So this is you have to juggle with a lot of things here, right? So as much information we capture is good, but at the same time we need to take the time or help with this AI tools to do the analysis of all that information. I will say that.
Great. Thanks, John. Anybody else?
Yeah, I just think don't forget the physical response from the slope. The crest loss and the effective burn width that you're measuring on a routine basis is part of the blast reconciliation process, and obviously it's an absolute key one because crest loss. It's the same word. I'll use it all the time. And if you don't control crest loss in your blasts, then you won't achieve your slope design criteria, and you'll end up with flatter slopes. So, rule number one is control of the crest loss and achieving the design criteria.
Here, Phil. If the design is not being achieved, then there are two options available. Operational performance needs to be improved, the design needs to be adjusted. Those are your two options.
We're going to make t-shirts.
And changing the personnel involved.
Oh, very good.
And maybe
All
just going back, sorry, just going on the radar stuff, look at how long it takes for the slope. If you've got a moving wall, look how long it takes for it to come back to the rate that it was moving at. Was it moving at all? You shoot your shot, it's probably going to have a response. And then 2 hours later, is it good? Does it take 24 hours? Is it 15 minutes? And keep a note of that. That is valuable information. And plot that up. Plot it up against your PPVs and your frequencies, and adjust accordingly.
Yeah, great point. All right. Thank you for the question, Jaffney. Phil, you just made my life much easier because I'll just go to this question right here. How do you address persistent crest losses? I'll start with Phil.
Give this one to Pat.
No, yeah, I think Pat, you can start, mate.
All right. Well, I mean, one of the key things here really, it comes down to the recoil direction of your shot and back brake. How much damage are you doing to that crest through that trim shot or the modified production that you're shooting? I think the first thing to address is what that recoil direction is. And then from there, we have to adjust or address things like, well, what are the structures telling us? Do we have adverse oriented structures relative to the direction that we're shooting it? And then take that into consideration. Those are some of the key things that I think need to be, or at least the conversations that need to start with the issues regarding crest loss.
Yeah, clearly, crest loss can be affected by. You may have some problems with the location of your blast holes on the previous benches and where they are in relation to your crest. So something that I see that a lot of mines are getting better at now is trying to make sure that you've never got holes with sub-drill sitting right over your berm or near adjacent to the crest. And when you get persistent crest loss, there's only two things that are doing it. It's geology and it's energy that's coming from the blast adjacent to that crest. So the key thing here, again, we keep coming back to vibration. If you don't do any monitoring of what's happening when you are blasting and having a look at the PPVs that exist at the crests or just behind them versus what you're modeling or what your intention is, and the critical PPV for the rock mass that you're in, you can never improve. So it's persistency to me usually means that there's a lack of feedback or QA/QC going on, and it's sort of business as usual. So that's my impressions about things. Sorry. Cheers.
I would add that sometimes the bench face angle or the batter angle can impact all of that, especially when you get into flatter bench face angles, and you need to start thinking about how do you disperse that energy. It's again, if it's all loaded near the toe, you don't have a whole lot of energy up here. You can get either overhangs, or in one weird case I ran into, they were pushing the blasting further and further into the slope to avoid that, and then damaging the slope. And then the shovel operators would come in and they had this cultural value around digging to hard. So they would just keep advancing the dig until they got to hard rock. Didn't matter where the crest was. So it was this combination of a lot of different factors that they were really not doing at all well with design conformance because of all of these interrelated factors. So it's actually kind of a tough question. I mean, there's a lot of things that have to go into this one, because you can approach it from design conformance, energy dispersal, design, bench face angle, cultural values around, safety, quote unquote. There's a lot of pieces to this.
Yeah. And just to say that sometimes the structure will just dominate. I think it may not matter what you do, the structure will control it, and maybe it goes back to what Pat was getting at. The design does need to change a little bit.
Yeah. I mean, you just run into it where you got to do something different, and it could go pretty far afield as far as what that different is.
Right. Very good. All right. Thank you for the question, Kofi, if I'm pronouncing that correctly. Let's go to the next live question here. This one is a bit more of a technical question. How do we orient a blast when we have structure like bedding parallel to the wall and a dip lower compared to the slope dip? I'm sure this is something that people face all the time. Maybe I'll kick it off to Ray.
This is a pretty classic one where you're going to have to adjust that design. And you run into this all the time where, especially with again, it's a cultural thing. I've been at one site where you go to some operations and they think this is the limit of what a 4100 can do. It can't go any steeper than that. And you go to another operation within the same organization, and it's like, this is what a 4100 can do. It can't dig any shallower than that. And those are two very different angles. So a lot of this really comes down to aligning the structure with the design. Because otherwise you're just going to be fighting crest loss all the time. Anything that's going to be steeper than that friction angle for the bedding, but shallower than the bench face angle is pretty subject to failure. You'd have to have some incredibly short structures to not really be a problem. And if you're talking about bedding, then that's not going to be the case. So it's really, in my mind, this is a pretty classic redesign, the design in terms of addressing this issue.
Great. Anybody else?
Just one other thing to consider here. We're in a situation like that, where the performance, the post blast performance of that bench face is likely going to be significantly influenced by that cohesive component of strength, not just the friction angle. So what do we do to try and preserve that? Things like reducing the amount of gas that's generated from the shot, providing relief, someplace for a trim shot to go so that gas pressure doesn't go up dip into that bedding and dilate that bedding even more and make the situation worse. So, but you really have to give it a lot of thought. And, that's something else to consider in addition to what Ray identified.
Yeah. I think that cohesion is a great point. We were having an incipient foliation to deal with. We actually figured out we could undercut it and it would stay there if we were nice to it. And then there was other times where we just had to sort of embrace this thing and put in some stab rows and break it off ahead of time so it would come down to the shovel. And that was the best option there.
I think some of the issue that you guys are talking around here relate to the fact that the slope design in the mine plan has probably got a pre-split in there, and it's a 70-degree BFA when you've got a 41-degree bedding dip out of the face, and it should never have been there, really. There are some situations where pre-splitting is not the solution, and obviously there's a critical angle at which the more Coulomb criteria mean that it doesn't matter what your cohesion is. With repetitive blasting adjacent to a slope, your cohesion is down, and something up around 40 degrees, you're going to be lucky if you've got bedding dipping out of the face above that sort of an angle, and not have a slope that's going to end up basically sub-parallel to your bedding structure.
Yeah, that's where you sort of get into that footwall mining. You're just going to bench down along the footwall and follow that bedding, and then step out every once in a while.
Yep.
But that's where design is really the answer to that.
Yeah, or dip slope it if you can try and optimize it that way.
Yeah, exactly.
All right. Perfect. Thank you all. Thanks for the question, Abdoulaye. Okay, let's see. We got time for maybe one or two more questions here. Let's see. Got a question from Andrew that just came in. Does the geology change in a pattern affect the loading? If so, to what extent does it affect the overall blasting? Say a change from fresh diorite to a high clay, highly altered and weathered diorite. Thank you, Andrew, for the question. I assume the answer is yes, but maybe I'll be wrong.
No, you're right. Yeah, definitely. When you do the design, the blast design, there is some factors to consider, and one of them is the impedance. So definitely, you want to apply to the rock the energy according with the rock strength. So definitely, it's different. The different materials needs to have different explosives. Is what I'm trying to say, and that will optimize the results. So that will be the straightforward answer.
Yeah, and it probably comes down to, like I say, the capability of the operation. I mean, it's nice to say, look, we'll drill it out and then we'll have a look at the cuttings and then we'll update maybe our plan. And there's a secondary loading component to this where we then change the load. Maybe we can change the density of the product, or we can change the quantity to load it accordingly once it's all drilled out. But it can be hard to do, and yeah, it goes back to hearts and minds, and winning people over that way. And just there's some interesting work being done. I've seen it a few places now where you can use the specific energy of the blast drills. It's lots of data that comes from that. I think it might have been an R&D thing through the GC at one point. Anyway, it gives brilliant data on sort of basically strength of the rock and quality of the rock. And you can even see structures through it. And with more drill rigs, reporting that data in real time, you can generate some heat maps pretty quickly to see where the good rock is and where the bad rock is. And if you have a scenario, just like the one you mentioned here, that could get pinged pretty quickly if you're onto it. And then you could adjust your loading accordingly. So I think there's some interesting work in that space.
I think the extent of the differential too between the two different geology types is pretty important. I've seen where we go from incredibly hard rock to pretty soft rock in the bottom of the hole, and of course all the powders in the bottom of the hole, and the site was having to do a lot of secondary blasting, and that can be a pretty key indicator that you need to think about how you load those holes differently. If you just got all these house-sized boulders that you got to break up with secondary blasting, but it was because of that such an extreme differential in the material types.
All right, great. Thank you for the question, Andrew. Greg, I believe that it was John Danielson at BGC. I think he was doing a lot with.
He did a lot of it. I just didn't want to. I thought I'd be whinged at if I promoted BGC too much.
Well, I'll do it for you.
So thank you for that, James. You fell into the trap beautifully.
Perfect. All right. I think we've got time for one more question here. Go to this one here. What is the recommended blasting procedure or technique for excavations in close proximity to a final wall or infrastructure, often termed pit interaction blasting? And is a secondary chaining operation required to safely remove any resulting hanging or loose rock mass? It's an interesting question. Thank you for the question, Mahfoud.
I would say that's going to be a case by case basis. I mean, depending on the geology, this lithology, structure, etc. You may want to consider pre-splitting, or if you have adverse geology, you may not be able to consider pre-splitting in close proximity to the final wall. Just that earlier example about a dip slope condition or a footwall mining condition. You may not be able to do pre-splitting. So I think it's going to be a case by case basis, but in any situation, you're going to have to scale and scale properly, whether that's with a chain being pulled by a dozer or hung from an excavator, or using a long reach excavator to scale to minimize roll rock risk.
Yeah, and I think that the chaining thing is, I'm seeing more and more a reluctance to drag the chain behind the dozer just from a safety side. I don't know what you guys are seeing in the industry, but people seem much keener on having a good operator in a track hose scaling the face. And in extreme cases, you might hydroscale it if it's a critical piece of infrastructure. Hydroscaling can get off. I mean, it's an effort, but it can remove huge amounts of loose rock.
Yeah, just as a comment, I think chaining, certainly seeing less of, and part of the issue of that is that as we get better at trying to achieve steep overall slope angles or optimizing them, should we say, we haven't got berms that are sufficiently wide to allow safe operation of the dozer in the first place. I mean, as an absolute minimum, even if you've got a small dozer, you need probably 8 to 9 meters minimum width. And if you've got any toe or substantial variation in crest loss, then that becomes a dangerous operation. So certainly, I think using equipment that's specifically designed to the task for cutting down, bringing down any loose material to avoid you having to do any secondary blasting is good. And obviously monitoring is something that we would expect you to be doing adjacent to any infrastructure to ensure that you're not getting any far field or even near field vibration levels that are exceeding acceptable levels.
All right. Well, I think we are at about time there. Thank you for the question, Mahfoud, and for everybody. Before we sign off, though, I just want to give a plug for all of our professional development courses. This is kind of our series here. It's almost too many to list out on one slide. Just to note that our Fundamentals of Open Pit Slope Design course now has Spanish captions. We'll be working to get Spanish captions on all of our courses, but it does take time. And your obviously the Blasting and Pit Slope Performance course, you know what course that is. Geotechnical Fundamentals of Underground Mine Design is our next course that we'll be launching in September of 2026. So be on the lookout for that. Again, our Fundamentals of Open Pit Slope Design course has Spanish captions. You can scan the QR code here if you'd like to learn more about that. And I'm going to have to go off onto the next slide, so you can always find this on our website as well. And then a plug for our underground mining course as well. So with that, I want to thank all of our panelists and participants. It was a great conversation. Thank you for all the questions, everybody that tuned in today. And yeah, thanks for your time, everyone.
Take care.
Thank
Thank you.
Thank you.
Great discussion.
Pleasure.
Bye.